Right, so let's get started with our presentation. Today, the title of our presentation is really Introducing Proxima, a new material to revolutionize rim or reaction injection molding. During today's presentation, we're going to introduce our company to you, Exothermic Molding. We're going to go over a little bit about what reaction injection molding is and what are some of the benefits of it. And then we'll go into about the Proxima material, the material to revolutionize rim. We have a lot of experience with the Proxima material. I want to share that with you. And then we'll end the presentation with describing some of the services that Exothermic provides our customers. So let's start with a short introduction to Exothermic Molding. This year is our 50th anniversary. We were founded in 1971 with a business plan to provide reaction injection molded parts to the medical, electronic, and lab instrument markets. And actually, that's primarily what we do today, 50 years later. Our headquarters is in Kenilworth, New Jersey, where we have all of our manufacturing. You could see the picture at right there is our plant where all of our manufacturing is done. Our company is committed to innovation. We continually make investments in technology, equipment, and in our employees, really to provide the best quality parts that we can make. And our mission is to provide the highest value reaction injection molding services available. So let's go into what reaction injection molding is. It's a unique process that uses the reaction of two liquid thermosetting polymers. It is an exothermic reaction. That means it creates heat. You can see how this works here on the right. We have the two different containers of isocyanate and polyol, and when they're blended together, they're dispersed into a mold, usually an aluminum mold, and the two liquids react and form a solid. So some of the benefits of this process is that you have lower mold costs, which make it ideal for low volume and complex parts. And so our primary customers come to us because they have quite complicated enclosure parts with a lot of details. And this is the ideal type of molding process for that. The reaction injection molding creates strong, lightweight parts suitable for painting. And it's extremely cost-effective for specific applications when compared with standard hot plastic injection molding. And one of the main benefits is safe encapsulation of electronics due to low molding temperatures. And it's one of the reasons why people use rim molding. Another big benefit is the ability to have different thicknesses, part thicknesses throughout the mold. And that's another reason why people use rim molding, because that helps create large parts with very good structural integrity. So let's talk about Proxima, the primary focus of this presentation. Proxima really we feel is the material to revolutionize reaction injection molding. The material is a registered trademark of Materia, which we've just learned has been purchased by Exxon, and is a Nobel Prize-winning thermoset technology superior to polyurethane in almost every way. So in general, it's lightweight, it's stronger and tougher with better thermal properties. And it's a drop-in replacement for the standard rim materials. That means you can use Proxima with the existing molding that you have, or the molds that you have for with the standard rim polyurethanes. And you can design new parts with properties not previously possible to do with rim, because rim molding pretty much limited to the materials available to it. So there wasn't really isn't a large variety of materials available, and Proxima kind of makes that variety greater with a much superior material. Let's talk a little bit about Proxima. It's a groundbreaking advanced polymer technology based on dicyclopentadiene, DCPD, and a family of comonomers. Proxima thermosets derive their unique characteristics through a polymerization reaction enabled by a proprietary Grubbs catalyst technology. It's formulated to address high-performance applications unmatched by many of today's competing material technologies. So some of the benefits are that the parts that are created from Proxima are highly corrosion resistant, very abrasion resistant. They have a high impact strength, almost a ballistic strength, and high use temperatures. Other properties is that the material is exceptionally tough. It has a high impact strength and resistance to crack propagation for long-lasting parts with predictable life cycles. Basically, the parts are basically unbreakable. And they're lightweight. Densities near 1 gram per cubic centimeter are 10 to 15% lighter than comparable thermoset resins. Proxima also has excellent hot-wet properties, with extremely low water absorption of polyolefins combined with the thermal stability of thermosets, as opposed to polyurethanes with a much higher water absorption. So that's another big benefit for RIM, is that the material does not absorb water. We also have a low carbon footprint. Cradle-to-grave emissions are 47% lower than epoxy resins. And the resins also have a low viscosity, with quick molding of complex shapes, high filler loadings, and low void content, as low as 10 CP. Let's look at some applications for RIM and for this material. So our primary applications are housing and cover for medical device, laboratory, and scientific equipment. We also have structural components with a high quality finish requirement. Here are some of the other components that we, some of them are made with Proxima, some of them are made with standard materials. But one of the things about us is that we specialize in some of this finishing. So in addition to just making the parts themselves, we specialize in very high quality finishing for customers who are looking to dress up their products. And one of the projects that we're working on is the qualification of Proxima being used for a wheel. So I couldn't do this with the previous materials. So the exceptional mechanical properties allow the material to be used with such an application. And the material is suited for other parts such as wind turbine blades, robotic parts, aircraft or train, automotive structural parts. And particularly with RIM, we look at quantities in the 500 to 1,000 units per year maximum. That's kind of where the sweet spot is for this process. So a lot of companies are making products that don't have larger yearly quantities than that, particularly when you're looking at specialty medical equipment, laboratory and scientific analyzers, and other kind of industrial equipment. That 500 to 1,000 piece quantity fits a lot of those manufacturers. So it's really an ideal process for that. So let's go into some of our unique capabilities that include really assisting you from final concept to final production, including mold making. We're also getting into 3D printing here to help customers develop those first prototypes without having to buy tooling. And in that case, we've got partners that are able to make some of those large parts that would transfer easily to RIM. We can do that with some 3D printing for the low quantities. And then we go into making your molds with our CNC machines. And one of the benefits there is that really tightens the product development and product to manufacturing time cycle. Here you could see our sanding stations where we sand any of the imperfections out of the parts before they go into our painting. And we also offer optional automotive grade finish and final finishing, really to produce parts that that's really our strength, is to produce parts that manufacturers of high-end products can really be proud of, and to put high quality enclosures around them with finishing that really shows the type of products that they're making. So we've reached the end of the presentation, and I just want to open up now to questions. If anybody has any questions, I'd be happy to answer them. We also have one of our specialists online that can help answer any questions. So I'll open that up now for any of your questions that you have. Are any of you working on projects now that could use reaction injection molding? Be happy to hear that too.
Yeah, Gene, this is Dan O'Brien.
Yes.
I'm currently retired, but I am still working part-time at Armstrong as engineer. And what I'm wondering is, what are some of the differences of the Proxima material as opposed to some of the standard dicyclopentadiene products that have been around for a few years?
In what way? What differences are you looking in terms of the way the material itself, or what it is itself?
Well, certainly as far as, some of the chemical differences, some of the end properties, how are the parts molded with the Proxima different from some of the standard dicyclopentadiene products available?
Well, in general, the process, I can get you a little bit more detail on the actual chemical process itself, but basically the process is very similar, where you have the two different materials that are brought together and form a reaction. That reaction is a little bit hotter with the materials Proxima, and in general the look and feel, at first glance, the look and feel of the material is very similar, which is why it's a good drop-in replacement. The only real difference is the increased toughness and resistance to cracking, and the fact that it's not very brittle. It has a lot greater impact strength. I don't know if that answers the question good enough for you. But
well, I'm sure, I know the differences between standard rim, rigid rim, self-skinning rim, some of the low density rim parts that we make for thermal enclosures and things like that. But, and I do know the benefits of the dicyclopentadiene, all that you have stated, and it sounds good. We do currently have a series of parts that we are quoting that look like they could benefit from the either a standard dicyclopentadiene or the Proxima. Now, I was just wondering what makes the Proxima unique over some of the dicyclopentadiene products that are on the market now. It sounds like it might be pretty similar.
I have to check back. I mean, I actually don't have an answer to that question. I think there's some advantages that they've put together with it, but I'm not familiar with some of the competitive materials that are used in this way. I know there are some used in other ways, but I know that our company, our engineers at our company have worked very closely with Materia to optimize this for rim, because it's also used in other processes as well.
Yeah, with regard to the wheels and any kind of mechanical components that might have a high stress load at the mount points, is there any provision to add any kind of reinforcement, say around the lug nuts or anything like that, or are they bolted directly through the Proxima material?
That's a good question. I know that we are molded. Let me go take a look at the picture. I know that you could see in the picture you have those inserts molded in, and that's one of the things that the molding technique allows, is to put those inserts in. You see that in the picture?
Yes, and I thought that might be the case. We do
Right.
the same thing with some of the rigid rim materials and parts that need to be bolted in a high stress area.
Right. Now, do you do your own molding yourself, or do you outsource to companies like ours?
No, we do our own.
Okay.
I represent Armstrong up in East Syracuse, New York.
Okay.
Very familiar with exothermic. I started back in the 70s with Polyform out in Westboro, Massachusetts, and then transitioned to Armstrong. I guess my last question would be is how is Paul Steck? I haven't talked to him in a while.
Yeah, he's doing well. We're busy, and company's doing well. So
Yeah,
I think everyone out
certainly.
there. I think everyone out there is doing well, right? With all the supply issues, anybody that can have a good staff and can address the customer needs.
Yes, our medical customers treated us very well during the pandemic.
Okay. Does anybody else have any questions? Dennis, you came in a little bit late. Unfortunately, the presentation is largely over, but what I can do is share the recording with you.
Yeah, I apologize for that. I did not have a reminder set for this and totally missed on the start of it, but that'd be great.
Yeah, I'll get that. I'll get that out to you. Are you currently working on any projects for parts?
Actually, so what I'm involved with is developing reaction injection molding for some medical device parts that we're making in-house. So I'm just exploring more of the technology right now.
Sure. We'll be happy to answer any of your questions if you'd like.
Yeah, I was just kind of hoping to see what was going on in the industry with it. It's a new technology for me to deal with now, so I'm just kind of cutting my teeth on it. And
Are you planning to do that? You're planning to do that molding in-house?
Yeah, we actually have this past July we brought in a reaction injection molding system, and we got a mold earlier this year. So I've been playing around with trying to get that react chemistry all tuned up and everything. It's a fairly large scale up on our end here to go from like a 50-gram scale to 5 kilograms now. So we're working on that, and then ultimately loading in some what would be a surrogate for active pharmaceutical ingredients that will be loading into these devices.
Right. Okay. Well, we'll be happy to help you if you need be an additional vendor for parts.
Well, that's what I was kind of looking into and seeing what was going on out there and what services are available. So,
well, one of the things I would like to say that in addition to molding the parts, one of the things that is very important to understand is that there's also quite a lot of post-molding work that needs to be done. And that's really what we specialize in too, because the molding process isn't always that simple. So you might want to put you in contact with Paul. He wasn't able to make it today with this presentation, but he could probably give you some more pointers on what to look out for and why. I mean, we've been doing it for 50 years. So maybe we can help you.
yeah, and that's actually kind of the information we're kind of growing into now is we have limited knowledge in house, and I'm the current subject matter expert at this point, and we're the company that supplied the system has been a help on the mechanical side, but some of the other issues they're out of their hands, right? So, well, definitely that'd be a really interesting conversation to have.
Okay, sure. Does anyone else have any questions? Peter, any questions? All right. Well, if there's no other questions, I want to thank you all for joining us, and we'll get back to you with some more information and be glad to help you if you have any projects.
Thank you, Gene, and certainly give my regards to Paul.
Will do. Thanks. Bye-bye.
Bye-bye.
Take care.
Gene Bohensky, hello.
Gene, Paul Steck.
Hi, how are you?
All right, is the webinar over?
I just finished.